In this video, we're going to take a look at a sample problem involving average atomic mass. Let's take a look. So here we have some data, and we have two isotopes of boron. And to calculate an average atomic mass, you need to know two things. You need to know how heavy each isotope is, and then you need to know its relative abundance, or percent abundance. And so we have those two pieces of information. Now, this calculation will work if you have two isotopes, or 3, or 5, or 7. You just kind of repeat the process. So the formula to find the average is to take the mass of each isotope and multiply by its percent abundance as a decimal. And then however many isotopes you have, you just repeat that process. So in this case, I have two isotopes. So I will add it to the mass times the percent of second isotope. If I had more, then I would just continue that process and then add them all together. Now, the trick is to remember that we want to change the percent to a decimal. So we always move it two places over, no matter how big or small this number is. We're going to move it two places. So as a decimal, this will be 0.1991, and 80.09% as a decimal will be 0.8009. So we're going to take the mass times the percent of each isotope and then add them together. So my average atomic mass for boron will look like this: 10.0129 times 0.1991 plus 11.0093 times 0.8009. Now, by moving the decimal place two places here, converting the percentage to a decimal, that takes the place of dividing by 100, which we usually do when we're going to calculate this average. So before we calculate this out, we should kind of think in our minds, what would a reasonable answer be? And we know that an average always has to be in between the two values. So it's going to be bigger than 10.0129, and it should be smaller than 11.0093. Also, since the majority of it, 80% of it, is boron 11, we would expect that the average is much closer to 11 than it is to 10. So we want it to be between 10 and 11 and closer to 11. And if it's not those two things, then we know that we miscalculated. So let's enter numbers in and see what we get. 10.0129 times 0.1991 plus 11.0093 times 0.8009, and we get a value of 10.81. So that's the average atomic mass in AMU. You could go out another decimal place if you want. So for boron, if you look on the periodic table, you're going to see something similar to that, because this is actually how we calculate the value on the table for boron.